Hi students, welcome you all again back to Venkat Varma Chemistry YouTube channel. I hope all are doing well. The previous session we learned about hydrogenation of alkenes and alkynes in the methods of preparation, hydrogenation of alkenes and alkynes. In this session I am going to discuss about reduction of alkyl halide. In this session we learn about reduction of alkyl halide. Let's start our session. Reduction of alkyl halide. The reduction of alkyl halide. First of all, what is a reagent for reduction of alkyl halide? What is a reagent? See, which reagent used for the reduction of alkyl halide? The reduction is metal acids, metal acids, metal acids, zinc in hydrochloric acid, HCl, or zinc in sodium hydroxide, or zinc in acetic acid, zinc in acetic acid, and zinc copper couple in copper couple ethanol C2H5OH. This is the reagent used for the conversion of alkyl halide to alkane. Alkyl halide to alkane. See, generally alkyl halide in presence of reagent like zinc H plus, it is converted to alkane. It is converted to alkane. See, except fluorine in alkyl halide, except fluorine, all alkyl halides are involved in reduction of alkyl halide. Reduction of alkyl halide. See, alkyl halides. See, alkyl halides except fluorine. See, except fluorine, except fluoride. Reduction with nascent oxygen, sorry, nascent hydrogen to give alkane. See, generally alkyl halide RX with zinc in H plus ion. H plus ion from acid, it give alkane and Zn2 plus and X minus. So what is the mechanism involved in the reduction of alkyl halide? Now go for mechanism. See, generally zinc is converted to Zn2 plus and loss of 2 electron. See, in alkyl halide, carbon and halogen is more electronegativity than carbon. Halogen is more electronegativity than carbon. So the bond is cleavaged. See, alkyl halide, the bond is cleavaged. It becomes R plus X minus. So in R place, it taking one electron, it becomes, see, it becomes like this. When Taking another electron, it becomes R minus. It becomes R minus. See, the R minus with H plus from acid, it becomes RH. It becomes RH. This is the approx mechanism of reduction of alkyl halide to alkane in presence of zinc in hydrochloric acid. Zinc in hydrochloric acid. See, have a look for next one. Zinc with sodium hydroxide. Zinc with sodium hydroxide. It gives Na2, ZnO2. It releases hydrogen. It is a atomic hydrogen. It is a nascent hydrogen. It is a nascent hydrogen. See, again alkyl halide with nascent hydrogen. Nascent hydrogen is a more reactive. It becomes RH and HX. This is a mechanism of zinc in HCl, zinc in sodium hydroxide. Have a look for example. See, generally methyl chloride in presence of zinc in H plus ion, it gives methane. It gives methane with the zinc chloride. Again, ethyl chloride with zinc in HCl. It gives CH3. So it is a ethane. So generally, a removal of halogen, adding of hydrogen. See, removal of halogen, adding of hydrogen. In this reduction of alkyl halide with zinc and acid. See, again, one more example. CH3, CH2, Cl with zinc in HCl or H plus. It gives what? CH3 plus ZnCl2. It is a propane. Propyl chloride to propane. Again, one more example. See, cyclohexane with chlorine in presence of zinc and H plus, simply removal of halogen, adding of hydrogen. It becomes cyclohexane. This is the reduction with zinc with HCl and zinc with sodium hydroxide. So, in this reduction mechanism, different types of reagents are used. So, what is the different types of reagents? See, have a look for reduction with lithium aluminium hydride. Have a look for reduction with lithium aluminium hydride. See, reduction with lithium aluminium hydride. In short, LaH. The reduction is carried out in presence of lithium aluminium hydride. See, in this lithium aluminium hydride proceeds SN2 mechanism. See, it proceeds SN2 mechanism. With the hydrogen acting, see, the hydrogen acting as nucleophile, H minus, hydrogen acting nucleophile, LaH. So in this reduction, primary alkyl halide with LaH, it gives primary alkene. primary alkane. See, secondary alkyl halide with LIH, it gives secondary alkane. I will look for tertiary alkyl halide with lithium aluminum hydrate. It gives alkene. It gives alkenes via elimination. Reaction. See, in tertiary alkyl halide to produce alkenes. See, have a look for example. See, alkyl halide with lithium aluminum hydrate. It gives alkene. Lithium halide, aluminum halide. See, it gives what? H minus. To produce H minus, its H minus act as nucleophile. I will look for example CH3, CH2, Cl in presence of lithium aluminum hydrate. What is the product? It gives CH3. Have a look for this example. CH3, Cl, CH3. It is a tertiary alkyl halide. See, tertiary alkyl halide with lithium aluminum hydrate, it undergoes elimination. Reaction to give alkene. CH3, CH2. It is a 2-methyl prop 2-ene. This is for lithium aluminum hydrate. Have a look for the next one. Reduction with sodium borohydrate. See, reduction with sodium borohydrate. NaBH4 SPH, in short SPH, sodium borohydrate. In sodium borohydrate, boron hydrate, see, it is a BH4 minus. Boron hydrate ion is softener nucleophile. It is a softener nucleophile. Compared to hydrate ion H minus. It prefer to target softener electrophilic location. Like secondary and tertiary alkyl halide. See, in sodium borohydrate, boron hydrate ion is a softener nucleophile compared to H minus, means hydrate ion. It prefer to softener electrophilic location like secondary, tertiary. For example, secondary, tertiary alkyl halide in presence of sodium borohydrate, it gives alkane. Secondary, tertiary alkane. See, primary alkyl with sodium borohydrate, it's no reaction. Primary alkyl halide, no reaction with sodium borohydrate. I will look for example. See, for example, butyl chloride, CH3, CH2, Cl in presence of sodium borohydrate. What is the product? So, no reaction with the sodium borohydrate. I will look for next example. CH3, Cl, 2-chloropropane with sodium borohydrate. What is the product? It gives propane. See, this is for reduction of sodium borohydride. Reduction of sodium borohydride. Next, reduction with the next reagent is the reduction with triphenyl stannic hydrate. I will look for next reagent. I will look for next reagent. See, reduction with the reduction with the triphenyl stannic hydrate. Triphenyl stannic hydrate. TPH. In short, TPH. Triphenyl stannic hydrate. Stannic hydrate. It is a reagent. Reduction of triphenyl stannic hydrate. See, have a look for TPH. So the triphenyl tinhydrate or stannic hydrate, it is primary, secondary, tertiary alkyl halides are converted to alkene. See, have a look for example. See, RX with triphenyl stannic hydrate C6H5 3SNH. Triphenyl stannic hydrate, it gives RH. See, this is for triphenyl hydrate or triphenyl stannic hydrate. It reduces primary, secondary, tertiary alkyl halide. It gives alkane. See, have a look for order of reactivity of different alkyl halide. See, order of reactivity. Order of reactivity of different alkyl halide. See, different alkyl halide. Different alkyl halide means alkyl iodide, alkyl bromide, yes, alkyl fluoride and alkyl fluoride. Which is more reactive? Alkyl iodide are more reactive than alkyl bromide, alkyl chloride than alkyl fluoride. Generally, alkyl fluorides are not involved in reduction of alkyl halide. See, see, alkyl iodides. See, alkyl iodides conveniently reduce to alkane by heating with red phosphorus and hydrogen iodide. See, alkyl iodide is conveniently reduced to alkane in presence of hydrogen iodide with red phosphorus. Hydrogen iodide with red phosphorus. In the reaction, red phosphorus remove I2 iodine as volatile and phosphorus triiodide, which makes the reduction of which makes reaction, otherwise it is reversible. See, in these reactions red phosphorus removes I2 as volatile phosphorus triiodide Pi3, which makes the reaction, otherwise reversible. See, phosphorus with iodine, it gives P PI3. PI3. See, this is for reduction of alkyl halide to alkane. Alkyl halide to alkane. See, have a look for questions. Have a look for questions. See. Have a look for question. Which of the following alkyl halide cannot be reduced in zinc and dilute HCl? Which is not reduced. So which is not reduced? So alkyl chloride is there. Alkyl. So alkyl chloride, it reduces to alkane. Yes. Alkyl fluoride, it reduces to alkyl. No. See, alkyl bromide, it can reduce alkyl alkane. Alkyl iodide, it reduces to alkane. Yes, it reduces to alkane. It reduces to alkane. So it does not reduce. So our option is second one. Have a look for next question. Have a look for next question. Which of the following alkyl halide in presence of hydrogen added with phosphorus to give isobutane? Isobutane. See, which of the following alkyl halide in presence of Hi in phosphorus gives isobutane? See, isobutyl chloride. Isobutyl chloride CH3 CH3 CH2Cl. It is a isobutyl chloride with a hydrogen iodide with phosphorus. It gives what? CH3 CH3 CH3. It is a isobutane. Next, CH3 tertiary butyl chloride. So it is a tertiary butyl chloride with a hydrogen iodide with phosphorus. It is also give isobutane. Have a look for secondary butyl chloride. See, secondary butyl chloride. Secondary butyl chloride in presence of hydrogen added with phosphorus, it gives what? Propane. CH2 CH3. So our option is isobutyl chloride and tertiary butyl chloride. Option is the third one. Option is the third one. I will look for next question. By the reduction of alkyl halide, we get alkanes. What is the best reagent? What is the best reagent? By the reduction of alkyl halide, we get alkanes. The best alkyl halide is fluoride, bromide, chloride, iodide. Which is the best? So, alkyl generally, alkyl fluoride cannot reduce. Yes or no? Cannot reduce. Cannot reduce with HCl. With HCl. So the carbon fluorine bond is a strong bond. Yes or no? Carbon fluorine bond is a strong bond, and alkyl fluorides. See, and alkyl fluorides are thermodynamically chemically stable. Thermodynamically and chemically stable. By the reduction of alkyl halide, we get alkane. The best alkyl halide is a so it is a alkyl iodide, it is a alkyl chloride, it is a alkyl bromide, alkyl fluoride. So it cannot reduce. So this option is not correct. Bromide, chloride, iodide. See, these three are can reduce to alkane. So which is the best? Which is more reactive? Alkyl iodide is a more reactive. because of carbon halogen bond length is carbon halogen is longest bond length and most reactive, which is option or option is fourth. Option is fourth one is a or option. Fourth one is a option C. This is for a reduction of alkyl halide to alkane in the methods of preparation of alkene. I hope like this video. Don't forget to share your friends. Don't forget to give like. If you find this content valuable, make sure to subscribe for insightful lecture. Thanks for watching.